Hello, my dear students. In this video module, I am going to present in front of you the basic concepts related to the topic calendars. In the first part, we are going to talk about the concepts related to odd days, and then we will talk about the concepts related to leap year and non-leap year. Let's get going. The concept related to odd days. Let us assume today it's Wednesday. All right. So today I'm writing it here. Today it's Wednesday. So let me ask you, what is 0 days from today? 0 days from today is today itself. So 0 days from today, I can say it is Wednesday. Okay. What about 1 day from today? Today is Wednesday. 1 day from today, it's Wednesday plus 1. So I can say 1 day from today, it is Thursday. What about 2 days from today? Today is Wednesday. So 2 days from today, Wednesday plus 2, Thursday, Friday. So I am writing 2 days from today, it's Friday. Similarly, 3 days from today, it's Wednesday plus 3, Thursday, Friday, Saturday. Right? 4 days from today, I can say 4 days from today, it is Sunday. 5 days from today, in the similar logic, it's Monday. 6 days from today, it's Tuesday, right? Now, there are 7 days in a week, right? So, what about 7 days from today? 7 days from today, it's Wednesday plus 7, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. So, can I not see that 7 days from today, it's as good as 0 days from today? Observe closely. 7 days from today, it's as good as 0 days from today. So in the same logic, when I continue, I can say that 8 days from today, it's as good as 1 day from today. That is going to happen on a Thursday. All right. So 9 days from today, it's Wednesday plus 9, which is as good as Wednesday plus 2, Friday. So in the same way, 10 days from today, it's as good as 3 days from today. 11 days from today, it's as good as 4 days from today. 7 plus 4, I can say 11, right? So I can say that 12 days from today, it's as good as 5 days from today. 13 days from today, it's as good as 6 days from today. All right. So in the same way, 14 days from today, it is as good as 7 days from today. Again, it is as good as 0 days from today. Okay. So in this way, when I consider, suppose I am dealing with n number of days, n days from today. You know what I will do? I will divide that n with 7 and then find out what is the remainder. And that remainder I am getting, I will say that is nothing but the number of odd days. I repeat, suppose you are considering n days altogether. Okay. You divide that n with 7. Then you will get a remainder. That remainder, it is nothing but the number of odd days. Now, let us consider today it's Wednesday. 14 days from today. You divide this 14 with 7. You know that the remainder, it is equal to 0. So 14 days from today, it is as good as 0 days from today, which is as good as today itself. All right. So we see a cyclicity here, and the cyclicity when we are considering is nothing but 7. So in the same way, when I am considering 28 days from today, it is as good as 0 days from today. It is as good as Wednesday, right? So let me ask you, if today it's Wednesday, what is 50 days from today? What is 50 days from today? What should I do? Take 50, divide this 50 with 7. I know that 7 sevens are 49. So I know that the remainder, it is equal to 1. I can say 50 days from today, it is as good as 1 day from today. Today being Wednesday, 1 day from today, it is Thursday. So 50 days from today, when I count, I can say it's going to be on a Thursday. All right. So in a nutshell, when I consider what is this odd day or it's all about, when I'm considering n number of days, what I should do here is I should divide the 10 with 7 and find out what is the remainder. I can say we are basically doing the modulo 7 operation, right? So when you're dividing the 10 with 7, what is the remainder? The remainder is nothing but the number of odd days. All right. So let me give you another example. Today, it's Wednesday, I'm considering. Okay. So what is 73 days from today? 73 days from today. What it will be? I can say 73 days from today. 73 by 7 when I do, I know that the remainder it is 3. So it is as good as 3 days from today. And 3 days from today is Wednesday plus 3. Thursday, Friday, Saturday. I can see that 73 days from today, today being Wednesday, it's going to happen on a Saturday. Okay. So this is the basic logic that you have to understand about the concept of odd days. Now, let us consider the number of days that's there in a given year or in a given month for that matter. January, it consists of 31 days. All right. February, depending upon whether it's a leap year or a non-leap year, the number of days will vary. It may be 28 or 29. Okay. If it's a leap year, 29. If it's a non-leap year, it's 28. March, it's 31 days. April, 30. May, 31. June, 30 days are there. July, it's 31. August, it's 31. September, it's 30. October is 31. November, it is 30. December, it's 31. So, using the fifth rule, you can find out the number of days in a month. When we are discussing this concept in the classroom, you can ask me what is that fifth rule all about if you don't know. So using that fifth rule, you can find the number of days in a month easily. So use this table for your quick reference for doing the calculations. Now, let's talk about the concept of leap year and non-leap year. I mentioned in the previous slide, February, depending upon the situation, whether it's a non-leap year or a leap year, the number of days, it may vary. For a non-leap year, 28 days are there for the month of February. For a leap year, 29 days are there in the month of February. So, what is the criteria to check whether a given year it's a leap year or not? So, let's consider an year, say 2024. This year, let's consider 2024. I know that 2024, it is divisible by 4, right? 2024, this number, it is divisible by 4. So I can say that 2024, it's a leap year. Similarly, 2028, 2032, 2036, 2040, all those numbers under consideration, they are divisible by 4. So all those years under consideration, they all will be leap years, right? So when I'm considering an year, say 1984, I see that 84, it is divisible by 4. So 1984, it's a leap year. Now, consider centuries. I can say that centuries like 2000, 2400, 2800, 3200, 3600, these century years, we can consider that they all are leap years. Please note, 2100, it is divisible by 4. But 2100, please note, it is a non-leap year. Calculation is based on that. If it's a century year, it should be divisible by 400. Otherwise, it should be divisible by 4. That is the criteria that you have to keep in mind. Okay. So 2100, 2200, 2300, all these century years, we can see that they all are non-leap years. Okay. 2400, when you consider, you can see that it is a century year. It is divisible by 400. So 2400, it's a leap year. Similarly, 2800, 3200, 3600, 4000, they all are leap years. So I shall sum up the proceedings. If it is a century year, it should be divisible by 400. Otherwise, it should be divisible by 4. Okay, if so, we can consider that the given year, it's a leap year. Okay, now a leap year will have 366 days because February has got 29 days there. So total number of days under consideration in that particular leap year, it will be equal to 366 days. And this corresponds to 2 odd days. You divide 366 with 7. Okay. So you can see that 7 5s are 35, carry over 1 36, 7 2s are 40. So you can see that it's 16 here. So then the remainder under consideration, it is equal to 2, right? So for a leap year, it is associated with 2 odd days. So make a note of this. Leap year, it's associated with 2 odd days. And what about a non-leap year? For a non-leap year, it consists of 365 days. So it is associated with 1 odd day. All right. So make a note of these details. Now, let's talk about the January 1 associated with certain years that I have listed here. Okay. Whatever that is highlighted in red color, it corresponds to leap year. So you can check the calendar, January 1, 2000, AD 2000, it happened on a Saturday. Okay. So 2000 being a leap year, because 2000, it is divisible by 400. So 2000 being a leap year, you can consider that it is associated with 2 odd days. 366 days, 2 odd days. So when you travel from 2000 to 2001, you should add 2 plus 2. So that is why Saturday plus 2, Sunday, Monday. We can see that 2001, January 1, it happened on a Monday. I hope this part is clear to you. I repeat, you look at the calendar, 2000, January 1, it happened on a Saturday. 2000 being a leap year, it is associated with 2 odd days. So Saturday plus 2. You can see 2001, January 1, Saturday plus 2, Sunday, Monday. January 1 happens on a Monday. 2001 being a non-leap year, the number of odd days, it is 1. So you go for Monday plus 1. You can see that 2002, January 1, it happens on a Tuesday. Similarly, 2002 being a non-leap year, 365 days are there. It is associated with 1 odd day. So when you travel from 2002 to 2003, January 1, you have to consider Tuesday plus 1. So January 1 of 2003, it happens on a Wednesday. Similarly, 2003, January 1 to 2004, January 1. Okay. you are traveling only up to January 1. You are not crossing the month of February. So please note that. So 2003, January 1 to 2004, January 1, you are considering a non-leap year because you are considering the month of February in that travel. So it is associated with one odd day. So Wednesday plus 1, you can consider Thursday. January 1 of 2004, it happens on a Thursday. Okay, and this process, it continues. And that's what I have presented here. Okay, so you can see Saturday plus 2, Monday plus 1, Tuesday plus 1, Wednesday plus 1, Thursday. Here, 2004 to 2005, when it comes, you can see that it is plus 2 because 2004, January 1 to 2005, January 1, it involves a leap year transition. So plus 2 you should do. Thursday plus 2, Friday, Saturday. 2005, Saturday. Then remaining, it's plus 1 Sunday, plus 1 Monday, plus 1 Tuesday. But again, 2008 to 2009, when you consider, same logic, it's a leap year transition. So Tuesday plus 2, Wednesday, Thursday. You can check the calendar, 2009, January 1, it happens on a Thursday. And then again, plus 1, plus 1, plus 1, plus 2. So it continues the cycle, plus 1, plus 1, plus 1, plus 2. Sunday plus 2 is Monday, Tuesday. Again, plus 1, plus 1, plus 1, plus 2. Friday plus 2, it is Sunday. I hope it is clear to you. Okay, Sunday plus 1, Monday, Tuesday, Wednesday, Thursday, Friday. Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. Like that it goes. We can see 2025, January 1. The upcoming leap year, 2025, January 1, it's going to be on a Wednesday. Okay, 2024, Christmas, it's happening on a Wednesday. 2025, January 1, it is again happening on a Wednesday. Okay, so we can validate all these results by looking at the calendar. So please remember the cycle, it is plus 2, then you go for plus 1, plus 1, plus 1, then you can go for plus 1. Okay, so it is something like Saturday plus 2, Sunday, Monday, plus 1, plus 1, plus 1. Then Thursday, here you should go for Thursday, plus 2 you should go. So it is like plus 2, plus 1, plus 1, plus 1, plus 2, plus 1, plus 1, plus 1. Okay, and here we can see that it is plus 1. So you can say Thursday plus 2 you should consider. Tuesday plus 2, Thursday, Friday. I mean Tuesday plus 2, Wednesday, Thursday, I mean. Okay, so like that, the cycle actually continues. Okay, I hope this part is clear to you, how the transition actually comes. So whenever you are traveling from a leap year to a non-leap year in this way, you should go for a plus 2 logic. Saturday plus 2, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, and this process continues, so on and so forth. So you can take a screenshot of this for your quick reference for understanding the January 1 new year for these upcoming years, how it comes, and this will help you a lot for solving problems. Okay, now there is a concept related to the calendar reusability. Every leap year in general repeats over a span of 28 years. Okay, if the year it is in the pattern leap year plus 1, it repeats over a span of 6 years. For leap year plus 2 and leap year plus 3, the cyclicity is 11. I shall explain what it is. So please make a note of it. Leap year, it is 28. Leap year plus 1, it is 6. Leap year plus 2, it is 11. And leap year plus 3, it is 11. Now, consider 2000. You know, 2000 is a leap year. 2000, that calendar, it can be reused again after 28 years. So 2000 plus 28, 2028. So I'm saying that 2000 calendar, you can reuse it again in 2028. Let's have a look at this cycle here. 2000, you know, January 1 happens on a Saturday. You can see 2028 that January 1 under consideration, it is also happening on a Saturday. So you can use the same 2000 calendar on 2028. Okay, have a look at 2008. 2008, January 1, it happened on a Tuesday. 2008 being a leap year, 2008 plus 28, 2036. You can see that 2036, you can again reuse the 2008 calendar because both these years, they start on the same Tuesday and both are leap years. Kindly note, this particular 2008 calendar cannot be used once again anywhere before 2036. You can reuse it only on 2036. Okay, because 2008 and 2019, you look at it. You can see that 2008 starts on Tuesday, 2019 also starts on Tuesday. But you cannot use 2008 calendar on 2019. The reason, 2008, it is leap year, but 2019, it is non-leap year. All right. So you can use the calendar up to February 28. But after that, in 2019, it's going to be March 1. Okay, so that is why 2008 calendar cannot be used full and full in the year 2019 because of the leap year, non-leap year conflict. Okay, so make a note of that. So in general, as we can say, every leap year, it repeats in every 28 years. Look at 2012, leap year, plus 28, 2040. You can see that 2040 also happens on a Sunday. 2012, it came on a Sunday. 2040 also, it will be happening on a Sunday. So you can use the 2012 calendar again in 2040. And this is the cyclicity related to leap year. Okay, every leap year repeats itself over a span of 28 years. So the calendar reusability under consideration, leap year calendar can be used after 28 years in general. Okay. Now, if the year is in the pattern leap year plus 1, for example, 2025 is nothing but 2024 plus 1. Okay, that is 2025. So like that, if you see leap year plus 1, you can say the cyclicity, it is 6. So 2025 calendar, I am predicting that it can be used again after 6 years. That is 2025 calendar, it can be used again in 2031. I just now mentioned that January 1 of 2025, the upcoming new year, it's on a Wednesday, right? So I am now saying that 2031 January 1 also will be happening on a Wednesday. Okay, so that's my prediction based on this particular table. 2025, the new year is on a Wednesday. 2031, again, new year, it is going to happen on a Wednesday. Let's validate it. Look at this, 2025, Wednesday, plus 6, 2031. Yes, it works. You can see that after 6 years, 2025 calendar can be used again. All right. So make a note of this. We can see this happening in every situation. Look at 2033. It is leap year plus 1. Okay. 2032 plus 1 is 2033. Leap year plus 1. Okay. So the cyclicity is plus 6. 2033 plus 6 is 2039. You can see that 2033 leap year plus 1. It started on a Saturday. 2039, it also starts on a Saturday. So you can reuse the leap year plus 1 after 6 years. In the same way, if you verify leap year plus 2, leap year plus 3, in that format, if the year it is, it can be used again after 11 years. Let us consider one example, 2025. Sorry, 2026, let me consider. 2026 is 2024 plus 2. It is in the form leap year plus 2, right? So leap year plus 2, the cyclicity is after 11 years. So 2026 calendar can be used again after 11 years on 2037. We can validate it I'm saying 2026 and 2037, they are look alike. Look at 2026, Thursday, right? Plus 11, 2037. You can see that, yes, the reusability works. 2026 calendar can again be used again after 11 years, 2037, because both they start on the same Thursday. And it is applicable across this particular table that I have presented in front of you. So please make a note of this, the calendar reusability part. Leap year, you can use it again after 28 years. Leap year plus 1, it is 6. Leap year plus 2 and leap year plus 3, it is 11. That's the cyclicity. Okay, now let's consider some interesting observations here. In a leap year, January and July, I'm calling them as identical twins. It means both these months, January and July, they have 31 days and they start on the same day. We will validate this. Okay. In the same way, in every non-leap year, January and October, I call them as identical twins. Both they have got 31 days and they start with the same day. Okay, let's validate all these findings. Let us consider 2024. You know 2024, this year calendar, it's a leap year. So in a leap year, you can see the January and this July, they are identical twins. That's what I just mentioned. Leap year, January and July, they are identical twins. You can see that both these months, they start on the same Monday, as you can see. And both these months, they have got 31 days. So that is what I meant when I said leap year. This particular January and July, they are identical twins. Okay, because they are actually one and the same. You can also see January, April, and July. They all start on the same day. You can say January starts on a Monday, April starts on a Monday, July also, it starts on a Monday. And this is the speciality of a leap year. You can verify this for any leap year for that matter. Any leap year, January and July are identical twins. January, April, and July, they start on the same day. Okay. In the same way, you can consider February and August. You can see that they start on the same day, but they are not identical twins because February has got 29 days and August, it has got 31 days. So they are not identical twins, but February and August, I shall write it here, February and August, they start on the same day. Okay, it doesn't end here. I want you to consider March. It starts on a Friday. Look at November. November also, it starts on a Friday, right? So, can you not say March and November, they also start on the same day? Okay, all these, they start on the same day. Okay, so you can see that. And which day it is, it varies from year to year. But the repetition part, when we are discussing, this particular point, what I just mentioned, as far as leap year is concerned, you will find it very, very useful. So I shall conclude the discussion by saying in any leap year for that matter, January and July, they are identical twins. January, April, July, they all start on the same day. February and August, they start on the same day. March and November, they also start on the same day. You take any leap year calendar and then you can validate these findings, whatever I have mentioned. All right. Similarly, let's consider a non-leap year. I'm not going too far. I'm just considering the next year calendar, non-leap year, 2025. In any non-leap year, I can say January and October, they are identical twins. Look at this. It starts on the same day. And I can say that both January as well as October, they have got 31 days. So they are identical twins. Okay, January and October. Now, for any non-leap year, February and March, they start on the same day. Observe, February starts here on Saturday, March also starts here on Saturday. So for any non-leap year, you can consider February and March, they start on the same day. Okay, in the same way, if you observe April and July, you can see that they start on the same day. April starts on Tuesday and July also starts on Tuesday in this next year, I am saying. Likewise, any non-leap year, April and July, you can say that they start on the same day. In general, whether it is a leap year or a non-leap year, we can conclude that April and July always they start on the same day. Okay, so this you will find it very, very useful and handy. Okay, for solving questions. April and Tuesday, April and July, whether it is leap year or whether it is non-leap year, it doesn't matter. They start on the same day. Okay, you can see that happening both in leap year as well as non-leap year. Look at 2025, April and July. They start on the same day. Okay, look at 2024, April and July. They start on the same day. Okay, so that's another interesting point that you can note. So another interesting thing which I may say as far as the calendar it is concerned, the last day of a century, okay, the last day of a century, it cannot happen on TT-SAT. A short code I am telling you, the last day of a century, it cannot happen on a Tuesday. It cannot happen on a Thursday. And it cannot happen on a Saturday. Okay, that is I am talking about December 31, the last day of a century year. It cannot happen on TT-SAT, Tuesday, Thursday, Saturday. This is a common question that comes for many tests that involves logical reasoning. So this point, what I just mentioned, you will find it very useful. TT-SAT, last day of a century, cannot happen on Tuesday, cannot happen on Thursday, cannot happen on Saturday. It always comes like that. Okay. So using these points, what I have just mentioned, you can now start attempting the questions that I have shared through handout. And also you can use the explanatory notes for your quick reference. So keep your curiosity always alive and always be open to learn and explore new things. With this note, I'm concluding this video module. Thank you and take care.